Okay, let me see if I can improve my video skills. I make little mistakes where part of the schematic is off and in the twilight zone. So, okay. This session we're going to look at the IF filter. Its function is when you have RF from the universe coming through your bandpass filter and then being beat against the VFO frequencies, we're going to output 4. But we don't want to listen to a wide band, not for CW. We'd like to filter. We'd like to do everything plus or minus 150 hertz, 200 hertz, either side of the station we're listening to be attenuated, to be removed, so that we've got a clear signal. In order to do that, we use crystals because they have a number of qualities which I don't have time to discuss right now. But one of the things that, if you go and look at Wes Hayward's book on experimental methods in RF design and the ARRI handbook and electrical engineering books and everything, you can find all the mathematical details. What we want to do is we want to match these crystals. Now, the way to match crystals, are several ways of doing it. Some of them are complex, but we're going to take the simple route, and that is we are just going to find crystals which, when oscillating in a oscillator, all have the same or very close to the same frequency. Now, if this is your first project ever, or even if you've been doing this a while, there is a possibility that I've caught you when you don't have a crystal oscillator. So, thinking like a professor, I'm trying to determine a way for you to match crystals without having to go and buy something else. Well, it turns out that if you have all the parts to fabricate, to put together this transceiver, then we have what you need to match crystals. And let me show you how to do this. Got to think outside the box. Now let me find another schematic here. You can see I love highlighters. This is the transmitter section. Okay. Now it has a BFO. It has a 4 megahertz oscillator, which when beat against the VFO, which is at 3 megahertz, we're going to go through a mixer, but this time we're going to take the sum. 4 plus 3 is 7, so we've got a bandpass filter here that passes 7 megahertz. Then it goes through, there's another, we used it as an IF amplifier, but here it's just used as an RF amplifier, and then it drives the power amplifier to output our signal. Now, this VFO is not operational when the receiver is working because we have a key. When you key down, it's going to activate the B+, the 12 or 13 volts has got to come through Q12 here. This is our keying transistor. When this goes low, this transistor becomes active. The 13 volts is passed through here and then activates our amplifier and our mixer and our oscillator. So what I'm going to do here is I'm going to activate this oscillator. If this oscillator were running at the same time we're receiving, we're going to hear this thing. And I'm going to prove it in a minute. What I'm going to do is I'm going to bypass this. I'll show you. Now, get out your schematic and look. How can I get 13 volts to this oscillator? Well, it's easy. I'll start here at the emitter of Q12 and connect a wire from there to, let's go to here, to the positive side of C45. Do not connect this to the ground. You will short out 13 volts to ground and you're going to blow something. You're going to burn up a lot of stuff. So do not be sleepy, drunk, on drugs, or anything else while you're doing this. So here's my transceiver. I have not installed the IF filter because I haven't selected crystals yet. Now I have a collection of 4.032 crystals that I'm going to select from to make my filter. Okay. You go and buy these in quantities of 10 or 20 on eBay for 10 cents a piece. I'm ready to go. Let's fire everything up. Now there's my transceiver. I got it in the middle here. What do? Power it up. I'll power it up. I don't hear anything because I don't have a speaker. Here's the speaker, and I'm going to hide the leads this time. You know, you screw up once in a while and then we fix it right. Hear the hiss? Let's make sure it's still working. Where's my antenna? Now, this antenna is pretty short. It's only, what, 30 centimeters or so. X3 is where signal's coming in. Can you hear the voice? It's one of the local broadcast stations. It's coming through there. All right, now what I did is I hooked up. Now where's my? I got a short test clip here. I put in. Now here I built the BFO for the transmitter. That section that I had highlighted in blue. Now here I put a little header pin in the plus side of C45. Then I put another header pin in the emitter side of Q12. Now when I connect these two, this oscillator is going to start oscillating. Now let me just take one of these. This is a 4.032 crystal. Let me plug it in here. Now I don't have to solder. The leads are compressed here, so this will friction fit right here where X5 goes. See it stand off? Now always connect the B plus last. Alright, so there's C45. And here we go. We're going to start the oscillator. Now you hear that? Now the reason for the low tone is why? It's because this crystal is almost matches this crystal in the BFO of the receiver. So it's what is that? A couple of hundred hertz off? And the reason why it's off is because of this capacitor right here. If I short this out, then the tone will go lower. I'm pretty sure. Okay, there's crystal 1. Now remember the tone. Now I gotta undo this because it'll make a squealing sound. Another crystal with leads close together. Friction fit. Fire it up. That one might be 20 hertz lower or whatever. I played trumpet for 14 years, so I think I still have a pretty good ear. I guess there's an app. You could probably find a phone app that has an audio analyzer in there. They probably have it for people that play guitar or musical instrument or clarinet or whatever to tune. So look that up. I just thought of that. So, you know, there's an app for everything. Now remember, those two are very close together. Whoops. Well, let me show you what happens here if I do this. Let me get another. Okay. Hear that? Now the reason it does that, I think, is because I've got the crystal across the active pin, and I've got a very low capacitance between this pin and ground, and my body's helping complete the circuit. I've got a very low capacitance. It raises the resonant frequency significantly. So you don't want to hear that. I imagine it's pretty loud in the camera. So what am I up to? I'm up to 10 minutes already. I gotta quit. Okay. Do this one. This is number 3. Low tone. Okay, let me get another one. Put this one in here. Okay, now that one's higher, so that means that this crystal doesn't match the other 3. The other 3 are close. They're probably close enough for a filter, so I'll use those. And that's how you match crystals. If you want to do it precisely, then you're going to have to get a frequency counter or something. And then what you do on a frequency counter is you just measure the output. I think it's this capacitor here. Look at the schematic. Yes, C58. I think that's C58. And you can use a frequency counter, but I'm not going to do that. Okay, I've got to stop this. Let me go install it, and we'll come back. Now remember this. That's without the filter. Now, having installed the crystal filter, I've installed X1, X2, X3, and the 2 capacitors in the filter, and the coupling capacitor here, the 100 picofarad, the capacitor C11. Let's take our signal, which is, let's connect it to the vertical again, and let's, whoops, I got the wrong clip. Sorry about that, just to err is human. Now, let's see if we're still okay. Let's go back to C12. We got our loud signal. Now let me feed the signal in here between X2 and X3 so that I only have one crystal in the filter. And the AM station has disappeared. Just one filter is enough, but there would still be a wide bandwidth. If I go, I'm going to show you something. There's coupling between the case and the crystal itself. If I feed the signal to the case, now the case is isolated, that is not directly connected to anything on the crystal. The signal is fed through, coupling to the crystal, and you get some filtering. Here the noise is reduced, but the AM voice sounds louder. Not as louder. If I go to the end of L1 here, which means that I'm going to couple the signal through the coupling capacitor, through the entire filter, and that's the low end of L1. Well, the filtering is so good I don't hear anything. We're going to have to build the rest of the receiver to hear what's going on here. That's it. Appreciate a like. We'll come back. Oh, I forgot the quiz. I asked you last time to analyze L1C8. This is an LC network. At resonance, this thing has a very high impedance, what's the resonant frequency here? Well, do the calculation, is around 6.9, close to 7 megahertz. And I trapped you there because you need to read the web page for the original work that Steve did on this thing. And he did this because he was having trouble with a 7 megahertz broadcast station. Now, we're not going to have trouble with that, so we could leave that out. I'm going to come back and I'm going to put it in, but we're going to short it out. And now the signal from the mixer into the coupling capacitor will just feed through. I will put it in and then we'll do it with and without, and I can eliminate 2 parts there. Going to go off, build the mixer. Well, let's just build the whole thing. Let's put in the trap, let's build the mixer, and let's put in the bandpass filter. When I've done that, I'm getting signals direct from the outside world through 7 megahertz and into the filter. I shouldn't hear anything because this is at 4, but the signals are coming in at 7 and they don't match. In order to get things into the receiver, I'm going to have to build the VFO. So let me go ahead. Can I learn anything? Well, let's go ahead and do it. Build the bandpass filter and the mixer and the trap. Appreciate a like.